Hello everyone, we will continue our meetings Zoom. I believe that everybody already received the file that we sent to you to play with the second session. And this file should be open in the Matlab, and each one, it is a live editor file, and you can start from the first one, which named R2_1. Please open this file and I will open the share screen. Okay, I believe that everyone can see the screen, right?
Yes, we can see the screen.
Wonderful. Let's start.
Michal?
Yeah.
Did you send us the files?
Yes, I sent this. I sent two files, maybe more. The first one was about the last meeting about image processing, and this one was exactly for today's session about data analysis. About.
Okay, thank you.
You received it or not?
I'm checking. If it was in the mail, I will.
It was, yes, it was inside the mail. It was 2 days ago, in the beginning of the week. Okay?
Thank you. Yes, yes.
Yeah, you're welcome. And also, I know that several participants asked to speak maybe slowly, that you can just repeat all the commands inside the Matlab, and I will try. Also, please do it if you want to have this material at yours, please keep it, because only for the first meeting I sent it already filled up all the commands, and now if you need them, please you do it yourself, and this way you can have them. Okay, we will start from the regression analysis of the data. And regression is a method of estimating the relationship between the variables, for example, between the input and output, or different variables. And we can use linear regression, nonlinear regression, and also Matlab has itself several commands for this. Also, most important to use curve fitting toolbox that is inside Matlab and also can help us to do it. And to perform the regression from the very beginning, let's start with the example that I believe that you already know from our first meeting in May. We take the file from the Matlab that is inside, and just we can see what are inside, which variables are inside. There are cdate, and there is a pop files. Let's see. You can see that cdate is a vector, one column vector, 21 values in this vector, and population is also 21 values in this vector. We can see them as a graph. Let's plot them as population against date. And we can use, for example, circles to see it, and we can use also gridding. Okay, this is our graph. What it can show that the x-axis, there is a years, and on the vertical axis is just 1 million people in the United States. And these graphs show how the population increases during the years. And now let's try to build some analysis of these relations between the time and the population. First, we will estimate the correlation coefficient. Correlation coefficient just estimate the statistical relatives between the variables in two vectors. And correlation in Matlab is the function correlation coefficient, and we will use our input and output, date and population. We did not close the command to see the result. Okay, correlation coefficient, sorry. Coefficient. Okay, we have a small matrix, 4 numbers. The values from the left up values till the up down right values is just the correlation vector to itself. It's always 1. And correlation coefficient in the diagonal value, this value, they show that our time, C date variables and our population, they are really connected and related. Now we can check this correlation also to say it's linear in positive correlation or negative. For example, if I change the sign from one of the variables, minus, for example, minus population, you can see that our correlation coefficient is just minus. It means that, again, it is really correlated. These data are correlated, but they are negative correlated, negative correlations. Now we can use a command in Matlab to build a fitting curve for this correlation. And we will use a Matlab command polyfit. You already can use it just without Toolbox fitting, because this command works just in the Matlab. Let's do it. For example, we can make an estimation of the polynomial and the structure and the coefficient mu. I will explain later what it means. And we will use, for example, polyfit, and our C date, our input, and our output. Here we should choose the number of the coefficients, the degree of our polynomial. Let's start from the small degree, for example, just 2. When we get this result, we can see the polynomial itself. Let's see it. And I will close our title because we don't need it. You see our polynomial, it has 3 numbers. Why we have 3? Because we ask for 2 members of the polynomial, and we have a free member. This is why we have 3 members. Now let's try to estimate, to create, to see our result of this polyfitting by using polyval. Also, this command is inside the Matlab. We don't need any Toolbox. Let's do it. For example, it will be a second population, a new one, and delta also we will see what it means. Delta equal to polyval. Now, this is our polynomial that we already have. This is our argument, C date, and also our model and mu. Okay, let's plot now the results of our modeling. Our argument initial and the experimental, not experiment, the real data. We will plot with the circles again. And here we also plot the result of modeling, C date, and calculation its second variables, and we will use black color. Okay, let's do it with the gridding. Let me show you all the line, and let's keep this line by hold, and let's plot this delta. Delta just explain the minimum errors of this our estimation. Let's do it. Plot C date. Here we will use our estimation minus 3 delta, also our estimation with plus. Multiply, sorry. And also grid we have, and title we can open the title. Let's see if there is no mistakes. No, there is a mistake. Delta.
Draw delts instead of delta.
Okay, let's delta. Okay, let me show you. And here we can see grid. Where is our gridding? Why we have no gridding? Okay. See date. Hold on. Let me start from the beginning. Okay, now it's okay. Here the result, the circles show the real numbers of people during the years. The black line, it's our model, and 2 deltas from the plus and minus just show the errors of our estimation. And also for delta analysis, it's sometimes very important to analyze the residual. What is the difference between our model, our estimation, and the real numbers? This is just difference between them. We can just estimate this residual as a new function. Residual could be as a difference from our estimation and the reality. And again, we can just plot it in a new figure. And we can see the results by plotting against this time, this residual, and let's do it as stars, for example. And also maybe gridding. Why it is important, but sometimes if our residual has some kind of deterministic way, like kind of harmonics or maybe trend, it could be a signal to improve our estimation and our regression analysis. And residual just show also the value of our errors of estimation. Here it's just small numbers you can see from 2 or 4 millions relative to the 200 million population in the United States. This all what we just playing can be done in Matlab without Toolbox. Let's go to the Toolbox operation in fitting Toolbox Matlab. This curve fitting toolbox uses different method, and it is not always, but a majority of these methods, they are based on least square fitting, and they can just find a parametric model that describe our data. Let's take some examples. For example,
Mikhail,
yeah.
before going forward, please let them ask a question if there is any.
Okay. I'm ready for questions, please. We were talking about two Matlab commands, polyfitting, just to make a model, polyfit, and polyvaluation, just to get back the estimation, the theoretical model, that data. Just two commands, polyfit and polyval.
Mikhail, the plus minus 3 delta is the same, which is plus minus 3 sigma?
Yeah, it's just, it's a standard deviation for the estimation. Absolutely right. Also the mu, do you remember I told you that we use this mu parameter in the equation? This mu, there is two numbers in this mu, it's just a vector. The first mu is a mean value of our data, of our x, of our argument, of our dates. Here it's just years, it's the mean value. And the second value in this vector mu is standard deviation of the same years. It just helps sometimes to understand the result. Okay. No, residual also, it's clear. It allows to analyze our errors and to see if we have something bias, constant bias that we can also improve in the future. Also very interesting to know. Let's repeat the same command, the same operation by using fitting toolbox in Matlab. We will use a new variables. Let's take population 2. Population 2 is equal to common fit. And now, again, our argument and our function, experimental. And here we should choose the method of fitting. We will just use the same polynomial fitting. The name of the method is poly2, because 2 is a number of members in the polynomial. When we make this estimation, we can plot the results, or we can see this result. Now, when we use this fit command, it's something new. It's not a vector, it's a structure, it's element inside the Matlab. And let me show you how it looks. Let's run it. Here from the right, you can see that our now result, it's a model, and it has it shows the structure of the model and each coefficient inside this structure. When we have this, we can just plot it, but also plotting by using fitting command, also it's something new. When we plot, we should start always with this structure, with this element. This result should start from here. It's our element, population 2, and then again we should take the data, our argument, and we should take our experimental data, and we can see it with the grading. Here is the result fitting in by using the Matlab fitting toolbox. And it allows us to estimate models with different methods. Let's play with these some methods that are inside the fitting toolbox in the Matlab. We will do exponential model just in several minutes, and I explain why. We will we will not start, we will continue from power model.
Michael,
Yeah.
the fit model, we need to download it.
What should we?
The fit.
Fit, it's
Yeah.
it's a command inside the Matlab Toolbox fitting, curve fitting toolbox. Do you have it?
Okay. No, that is why it doesn't work. Okay, thank you.
You see, in my mail, I wrote, please be sure that you have curve fitting toolbox for our session for today.
Okay.
In my next, I also will send about toolbox that we need to play with the modern signal analysis process, because without toolboxes we cannot. Matlab is only a base number of procedures, but toolbox, there we already spoke about hundreds of toolboxes. They are very rich and they allow to make many other interesting things inside the Matlab, exactly for this curve fitting. Okay, any more questions? Let's continue with it. For example, the kind of power model. Again, we should make now it should be something more. Let's double P. It's our result, and it's a parameter. I will explain later. And fit command, we will use our argument cdate and our population experimental. And now we should choose the method. Method will be power 1. Okay, let's see. Okay, it's no mistake. Let's continue. We can see the structure of this result. Again, you can see the equation of this power fitting and the coefficient A and B. And also we can plot the result. It's again, when we use fitting, should start from the result, from the structure. The structure, it's pop double P, again C date, and our population. We can use grading again. We can maybe make a legend, but not so important. Here, the result of power fitting of the model. It's very close to but maybe this, the first one, polynomial, is better. Even second value polynomial is better than the power estimation. Now, let me show you the number of linear model types. There are a large number. We can have, with those who has fitting toolbox, curve fitting toolbox, can press this link. It's a hyperbolic link. You can go through internet. You can see the address, and just let's do it. And we will open in the internet. And here you can see, for example, polynomial models, the structure and the names of these models. Here you can see very complicated and polynomial for surface, for analysis, 3D results. There is another exponential, Weibull, Fourier, and Gauss random estimation power that we already use, this power 1, and many others. Do you have questions about the name of the models for fitting? No, let's continue. Also, you see this fitting doing manual way, it's just complicated because before we don't know exactly the name of this method. This is why this curve fitting toolbox uses a very interesting tool, which is interactive curve fitting application. Please write or use this CF tool, and we will get this. Let me start it. Can you see this graphic fitting tool. Now let me show how we can do it using this this instrument inside the fitting toolbox. First, here we should take and should write our name. We can choose any name that we need. Let's our first fitting. Then we should choose our argument. We already know that there is a population. Here, oh, sorry, argument is our date. And the white date, it's our population. Where is our population? Here it is. Now we can choose the method. Let me again show the name, that exponential Fourier Gaussian. You can see it, right? Let me just show each one. We can just, again, let's take the exponential. And here, this is the number of terms, the order of this structure. And we can see in details the fit options of this fitting. And also we have here the result of our fitting as a graph. And what is interesting, we can use this fitting graphic user interface as examples of building the comment inside the Matlab. Let's do it. Do you remember that I said that exponential fitting, it's a little bit more complicated doing it manually. This is why we can do it now in semi-automatical regime. How can we do it? Then we get this result. We can just see how Matlab uses this. Let's go to the file and ask generate code. In our file, we can see how it works. Let's take these lines and let's copy them. And do you have time to do it together with me? Can you open this fitting and go file save, generate code?
Yes.
It's enough time to you to do it? Okay. Now we return back to our Matlab. We'll go to where we have our exponential. Here it is, our exponential. Let's paste it here. And now we have a method, ft, it's our method. Options for this method, it's a non-linear least square. Option display, we don't need this display. We also don't need so precise result. It's enough to have here 9 and here maybe 2 numbers. It's enough. And now we can, but instead of X data, we have C date. And here Y, we have our population. Fit method, okay, option is okay, let's do it. Okay, we will get the estimation. Now let's plot the result. We can take something already from here. We have, again, because we use this fitting, first of all, we should start from the model, from here. Okay, and this way we can plot it. And grading, okay, let's do it. This is our model using exponential fitting. Any questions, please, and we can continue.
What is GOF?
GOF is just for estimation parameters. Let me no, I don't remember exactly.
I see.
Goodness of fit.
Goodness of fit.
Yeah, it's goodness of fit, right? It's something parameter, fit statistic just inside the structure. Maybe we can see it's our error, maybe indication of our error. Okay.
Can you return a bit back? Can you return on your last section in the exponential part?
Excuse me, please repeat the question.
Can you repeat on the last part again?
Okay, no problem. Let's do it together.
Yes.
Okay, let's just delete everything. Not everything, but maybe here. We spoke that it's quite difficult to make this fitting if you don't know the name of the models of these methods. This is why just please use this interactive fitting application, CF Tools, okay? I start this here. Let me just show again. We have start from the name. It doesn't matter. Here it could be something cuckoo. It doesn't matter. The X data, it's our argument. Here it's a date of the population. We choose C date. Y data, it's a result of this population. Of the dates, it's just population. We choose it here. In the middle of this graph, we should choose any method that we need for fitting. There are a number of methods. You can see exponential, Fourier, Gaussian. You see a lot of them. We can try any and choose which one is better for estimation. We just, because we need this exponential, we choose exponential. This is the number of the terms exponential. This is the structure of this equation. And that's all. The result we can see here. The result immediately we can see. When I choose something else, let's take Gaussian, for example. This is another result of fitting. But we need this exponential, here the result. Now I need to repeat everything that fitting toolbox did with this graphic interface. I would like to have it in myself in my Matlab file. How can I do it? I go to the file and I ask to generate code. Here, this generated code. Something in the beginning, it's not interesting. It's when Matlab did it, it's not interesting. We will start from the really fitting model to data. This first line, it's here, just fitting. But first, Matlab choose the method. It's exponential with 1 parameters. Then it has options. Nobody can maybe knows from the very beginning that the parameters should be non-linear, least square. And also it was important, it's capitals and not capitals letters. It's difficult to do it from not knowing about how it should be written. And we just repeat all these lines, we copy them. When we have them copied, we just go back to our, we don't need, we don't keep it. We go back to our Matlab, to our file. And here in the exponential mode, we just paste them the result. The result, now what we have type of estimation of fitting. We have options of fitting the second line. The option display doesn't important. Here we have the start point. Start point because exponential should start not from the 0. You can see this first value is very small, e exponential minus 15. It's very small, but not 0. We don't need so precise value. Just for the start point, it could be something close to this, also close to this. Now we have everything for fitting, and let's do it fitting itself. We cannot use X data and Y data because Toolbox already has it as a values, but we should use our real data. This is why we use our argument cdate, our function population, this method that we also can do it without. We can just, let me show you, we can just put here the name itself, exponential 1. It's the same, and options. And now the plotting this result. Let's do it. Let me clean everything and see if it works.
Okay.
Yeah.
I need, like, you say that one of the methods is nonlinear least squares, but do we have, like, usually, do we have other methods that we can use?
Yeah, I will show you. You are asking about the second arrow example about nonlinear estimation of nonlinear examples. Let's go.
And just
here you can see after our interactive curve fitting application, there is example of nonlinear regression. Okay.
Yes, but also I have a question about the starting point. Why can't we have it 0, 0 from the start?
And the start, because exponent could not start from 0. It should be some you know, Matlab also has, let's try, I don't know if it works, but there is epsilon. There is the smallest number in Matlab that it can use. Let's see if it works. I don't know, but let's try. Now, it can work, but not 0. You see, if I put here 0, I believe it will. Let's try. No, but 0, it also works. But I remember that for exponential should be something more, maybe small number, but more than 0.
Maybe if this point is x and y, right?
This point is options for start point for the model, right?
For the parameters or the x and y itself.
Yeah, you can. You can choose any. We can choose, for example. Let me check if you see it works also, because Matlab fit the value. It's only need this number only for the beginning to start. It's just the starting. Matlab just estimate it by using its own estimation by using this least square method. It's
this
not
is
so.
Starting point. This values of what? I'm not sure. Like
The start point.
Yes,
this,
for what?
For what? For this start point, just function.
Like x0 and y0. This is the point.
This start point for our argument. Argument and argument, start point of argument, and the value, start point of the value of the function, as I remember. But this number is not so important for fitting result, because Matlab just need to start, and then it uses this least square method to estimate the real model parameters. And for Matlab, it doesn't important. It should be for exponential mode. It should be not 0.
Okay.
Okay. Okay, now your question about nonlinear fitting. Okay. Nonlinear fitting uses nonlinear regression analysis, and it also returns the coefficient of nonlinear regression model, and we can maybe start just with the example. This example we have from Matlab, and I understand that the example is from chemical sub-issue field, because the name of the variables, let's see their name, reaction, it's our file that is reaction.
Michael?
Yeah.
This is just me, or I don't see the screen has frozen. Maybe I don't know if it's just me or everyone sees it.
The screen is frozen. Please, anybody also?
Yes, meaning I can.
We can see.
If all other our participants can see, it's not my problem, but I can restart Windows if you ask.
Works fine for me as well.
We can see.
No, if everything is something in the computer, I can wait. Maybe you can make a restart, or maybe Matlab first. Let's try from the Matlab, restarting Matlab, and then if it doesn't help, let's start from the Windows, restart Windows maybe. Okay. Okay, let's continue. We take from Matlab this file. This is a good example, and we can see what is inside. There are a lot of things, but we need only 3 of them. We use command whos, who can explain the variables itself and the value of this variable, the size of this. There is reactants, and also the rate and beta.
Where can we find, like, how do you decide which word to use with the purple?
No, because I already prepared this example, and I also use this example from Matlab. You know, let me show you why I choose only 3, why it is important. Let's do it. If I didn't choose anything and I ask just for variable, let's see the result. Can you see the number of variables in these Matlab results examples? Here there is all this what Matlab has in this. No, maybe let us clear first. Let's clear and then do it. And also here. Okay, there is a number of variables: beta, model, rate, reactance, x, y. But to play with our example, we need only 3 of them. What they are? They are just reactance, rate, and beta. What it means, reactance, it's our arguments. There are 3 different arguments that can are input to our model, and output of the model is rate. You can see that each our argument reactance, it has 13. It's a vector with 13 values, and there are 3 of them. It means that we have 3 different inputs, 3 different reactants, and we have only 1 output, rate. But it has name rate, and let's see what it is. Let's try to maybe to see what is this. I can try to plot it. Plot this is argument reactance, and our rate. And let's play it as stars, for example, with gridding. You see, it's quite difficult to see something with this result. Again, we have 3 different inputs and 1 output from this model. Let's do this estimation, non-linear fitting estimation of this complicated model from chemistry example. We will estimate our estimated model structure H, beta H, as non-linear fitting, non-linear fit. And here we use our input, reactance, right? And the output. Again, here we should know the model that we will use with nonlinear fitting. And Matlab recommends in this example to use Haugen-Batson model. And the name of the model is Haugen. And initial data of the initial fitting, initial parameter beta. If I don't, let's close and let's build them together. We will build now the real parameters beta that has inside this example and what we get from our nonlinear fitting, beta H. Let's run our example. Okay. You see the initial, the analytical model, it has this beta example. We took it from the example. This is analytical parameters of the model. And this is the model that we received from the Matlab toolbox by using this nonlinear fitting. You see, there is not exactly coincident, but they are very close from 1 to 1. It's 20% errors. It's just a good approximation for nonlinear model. Again, their Matlab, and also they understand that it's quite complicated to do it because, again, we need to know the name of the models. This is why they have interactive nonlinear regression tools, and these nonlinear tools can be started just using the same function nonlinear fitting, but without left side part. Let's do it. We can just take it from here. Nonlinear fitting, we have again our input, our output, and we don't need here the, we really need it, but we don't need to the left side. Let's start it.
Mikhail, what is beta?
Beta is here from the left side. We can see this beta. It's model parameters from the analytical model. This all this example was taken from the analytical model, and these parameters were used for building this analytical model. And from the right side, we get our example show the parameters that we get from our estimation. Beta is parameters of the model, nonlinear model, from the analytical presentation of this example.
I have a question.
Yeah, you're welcome.
When we plotted the reactants vs the rate, and they are vectors that don't have the same size, so how could you plot them together?
Yeah, we will do it in the next example there where we go to the interpolation. Now we are speaking only about the regression analysis. For regression analysis, the argument and function, they should have the same size. But interpolation, we will play with the different size. Okay?
Okay.
Now, let's try this nonlinear fitting. And wide, it should be reactants. Let me check. Function beta, why it doesn't work? Maybe with my nonlinear fitting, reactance rate. It was my fault. This interactive, it's not fit, it's just nonlinear tool. Sorry, it should be nonlinear tool. This is the example. Let's start it. Oh, it's a long, let me show all this screen. What we have now, we have the same model, but now it's much clearer, the result. Let me try to explain. Here, this model show 3 sections. You can see 3 screens. The first one is show the influence of the first reactant, XY, as other 2 are fixed, and we can now change its value of this first reactants and see how it influence, how it just make the results of our rate, our output. The same can be done from the second reactants and the third one. The tools model for nonlinear fitting can explain that this really a complicated model, and each reactance, each input, it has different influence to the model. The first one is just their decreasing value influence, and this is increasing, decreasing. But Toolbox, this nonlinear fitting, allow us to understand there is relation from the input to output of this nonlinear model. Okay? Any question, please? Okay, let's close this example.
I have a question, please.
Please.
How can you see in this tool any measure of the goodness of the fit here? Because I just see...
The goodness is just you see there are red lines, dashed lines. The goodness is just the size between these dashed lines. It's just the errors of this approximation. Here also you can see this number, plus minus. Can you see this number from the left?
Yes.
This is the delta or goodness of this modeling. When I play with this fixed number, fixed value of this first reactant, you can see that it changed its value. When I am here, it also play with the fixed number and also with this delta. Okay?
And the direction in which the fit is better is unknown in this way.
No, but you can just export. You can ask to export everything, all parameters of this model. You can export to your workspace, and you will get everything, including residual, your errors, and also parameters. Beta is just parameters of the model, and you will get everything. Just make export to your workspace every of this fitting.
What can we use this data for? Like we can see the errors that we have in the fit, but what can we do with that?
For fitting, you can choose another fitting model, because we use this Hogan-Watson model, but there are a number of other models. You can just ask for let me show you, you can choose any other, maybe better model. If you go to this nonlinear fitting and ask for help, and let's open it in the browser, and you can see there is a number of models. Let me show where this list of this model, nonlinear options. Here, there is our nonlinear regression function that we already used, but there is another one here. Here it is. You can see there is other weight function and model that you can use for your fitting, and choose something that is more precise maybe for you. Okay?
Yes, and sometimes, like when I try to make a fit for a function, sometimes I get very very good results, and sometimes I don't get that, and that's like I get bad results, and then I change the starting point, and suddenly I get a really good result. So is there any way that I can figure the best starting point for my model?
As I understand, starting point can just make any difference with the time of estimation, but not the result, because maybe if your starting point is more close to the real value, then Matlab can get the result much quickly. But the result, as I understand, it doesn't depend on the start value. Start value just to start this nonlinear fitting, but not it cannot just has any relation to the result. It's just starting. And if you are far from the real number, or your fitting will not work at all, or it will work many times. You will wait and wait. But if your starting point is close to the real number, it will get you the result immediately, as according to my experience.
Okay, thanks.
Now, the last example that I would like to show, this is an application of this nonlinear fitting to estimate the sign function with the error, with the noise. This example was written by Peter Sable. You here in this example, you have a hyperlink to this file itself taken from the Matlab Matlab community. And here the author of this example, Peter Sable. Now, let me show how it works, because it looks very beautiful. And now we will take this example this way. First, we should have this sign. Let's do the argument from the sign. We will start from -4 until 100. It's our argument. Mean value is 1. Amplitude, it's also could be maybe 2. What we have we should, for frequency, for sine, we should have frequency sine wave. It should be 0.5, or maybe, I don't remember, maybe 5. Okay, we will see it. And the phase value, let's see, 2 radians. This is our phase. Now our sine wave, it should be as mean value plus amplitude multiplied by sine. Inside the sine, we should have 2 multiplied by pi, multiplied by our frequency, multiplied by argument, plus our phase. And what else? We should have noise, because without noise, it's too simple. Noise, we will have random normal size, our input. I hope we have no mistake. Let me check. No, something.
Michal, can you move the mouse? Okay, thank you.
So mouse, see what we, A should be capitals here, sorry. Let's check again. Okay, no mistakes, let's continue. Now let's plot this sign. Plot sign, it's our argument, our function, and like this random we will make with the red circles. And let's go with grading. And let's also play labels. X label, it's just X. And Y label, just Y. Interesting if no something again. What is here? Sorry, I forgot to close this. Okay. Here, the result of this sine wave with the random noise. Can you see it, right?
Yes.
Yes.
It's quite complicated to get the pure sign from here, but we will try to use this sign fitting command file or procedure produced by Peter. It works very simple. It's just output from this file, from this command, and we will use sign fit and our argument and our function. That's all. Only one line. Now, this require to be plotted. Oh no! First, before plotting, we should just produce this estimated with nonlinear fitting. The estimated it can be, for example, estimated model. It is first mean value. It's his first number. Now mean value plus amplitude. It his second value. Multiply by sign. Again, our sign it's 2 pi, 2 multiplied pi, multiply by f. No, sorry, it's his parameter. It's third parameter that he knows now. Is the third parameter, multiply by argument, and plus the last one, it's his parameter, sorry, SP, the last one. Okay. What we did, we just calculate our estimated sign. Mean value, amplitude, frequency, and phase. Now, let us plot it. Let's plot together with our experiment noisy line. Let's do it first, maybe noisy. Let's keep it. And then let's plot the new one. It's also, no, sorry. For his model, it requires interpolation of the argument. Interpolation of argument, we'll do it this way. It should be new data for argument. It should be, for example, lin space. We will take our first x, our first x, and we will take our last x, and the number of these, it can be length of our x. Okay. Now let's plot the second one. We will use this argument and his new function xp, and no, it should be maybe yp. Let's this is yp, this is sign, this is argument. Okay, plot grid, hold on, this is a mistake, and here grid on. Let's see if it works. Okay, let's maybe change the color. Let's take black color, and I'm just clear everything, and let's see the result. Now you can see how from this experimental result with the noise, with the errors, we'll get the pure sine wave, which just fits our experimental data. Okay?
Michael?
Yeah.
Sine fit is unrecognized in my computer. You know why?
Yes, I know, because I told here is a hyperlink to this function. This function I took from the work from the Matlab community. In our first meeting in May, we spoke about that we have a lot of very interesting, useful applications that were written by community. And I took, you also can just let me show. You press this link, and you will get this. You see file exchange sign fitting by Peter Seibold. You can take it. It's not from Matlab, it's just from Peter, but it's very, very, how to say, useful and good example. Okay?
Yes, thank you.
Okay, now we can just stop with the fitting and we will try to make something in another subject. We will replace and go to the interpolation, okay? Somebody asked our last...
Ethan, can you go again to the back to R21? Yeah, thank you. I just didn't finish to type.
Yeah, you're welcome. But title maybe doesn't important. It doesn't important this title because...
No, not the title, to type all the plots.
Okay, let's wait. Also, some participants asked to make a short break, maybe 2-3 minutes to go to the bathroom. Would you like to have it? Because
yes, please, thank you.
We already have an hour. But
thank you.
Yeah, you're welcome. Let's start in 3 minutes. But you know, Ruben, you see, with this slow speed, we just what we can do, we just make maybe 10% of the what I prepared to explain about data analysis.
Maybe you prepared for 10 lectures. What can I do?
No, it's, you see, this is a very interesting material for data analysis. We should speak about histogram analysis. We should speak about distribution analysis.
Michael, maybe at least one thing they will understand good. And if you want, you can send them the examples just to go over them.
No, you see, okay, we will maybe what I prepare, and we have no time to discuss, I will send this file, but this file that we discussed, we will work together, I will not send, because if we send everything, nobody will work with us. If everyone will get it already in a ready style.
Michael, what's the sign fit function is based on? Is it
non-linear fitting? It is based on linear fitting. I can show you here. Let's make a new section break, and this again new section. Inside I can write edit this sign fit, and we will see this file. No, it was my mistake. Sign fit, sign, not sin, sign fit. Okay, can you see it? This is output from the file. This is input, only argument and function. And inside there is a, for the first estimation of the frequency, it uses FFT, but the main point that it uses nonlinear fitting. Let me show you. Here it is. Nonlinear fitting. This is why I took this example for the regression analysis, because it's a pure example how to get the complicated nonlinear result with the noise and get the pure result. And sign, everybody knows what it means, and I believe it's good.
Michael, the next toolbox is the statistics and machine learning toolbox.
It's a today we should use curve fitting toolbox and statistics, right?
Yeah, but we have in Matlab we have some kinds of statistics. So I asked what exactly.
Let me check my Matlab, because I remember only statistic. Let me check. No, only one statistic. There is no many statistics, only one statistics. There is only one, right?
I see statistics and machine learning toolbox.
Right, it's only one toolbox.
Yeah.
The name
okay.
is
Yeah, you said only statistics. That's why I'm asking. Okay.
no,
thank
because
you.
I just use only the first name.
Michael, could you please return to the last section, because I didn't copy
Sorry.
the last few lines.
Sorry.
Yes, I'm still copying it. Thank you.
Good for you, because I will not send it. Please tell me when you finished to continue.
Okay, I finished the copy.
Thank you. Let's
I downloaded the sign fit, but it's not working. It gives me undefined function.
It's very strange, because if it works in my computer, it should work at yours also. Maybe it is written, maybe you need additional. No, there is no need for additional toolboxes. It should work. What kind of error you get?
Undefined function.
Ah, because you should download it.
Yes, it is in the same folder of the other file.
Sorry, but let me check. It seems that I sent it to you. Let me check.
It has it.
Let me check if we have it here. Test.
Inside
it was in the mail with all the other files.
I sent, here it is. I sent you this file already. You have it inside.
I don't know why it's not working.
Maybe you write. Please check. Have you wrote this sign with small letters and F capitals?
Yes, I copied this name.
Isn't it what you said before, that I need to go to the Peter whatever? And
no, but he has already downloaded it.
Very strange. Okay. When you ask for the directory, can you see this function? Well, let me check. Directory S and star. Can you see this function?
Just a minute. Yes.
No. In this, can you open? Can you edit these files? Can you? Let's try. Can you open it?
Yes.
No, it should work. You know, they say if it looks like an apple and it tastes like an apple, it is an apple. It should work.
I also think so.
Okay.
By the way, how you check the dir s asterisk if you have it or not?
Sorry.
How did you run the dir s asterisk?
How I didn't catch you. How did I what?
How did you run the last function dir s asterisk?
The last function. You mean here in this screen, the last function?
No. When you now checked the problem with the sign fit,
right?
You ask, yes, in the other Yes, here you see the DIL.
It's a command from the DOS. This command, it may be 40 years old. It's directory, what file are inside. And you can see every file in this directory. But if you need the particular file which starts with the S, you can ask for S and star, and you can see only all file that starts from the S.
Very interesting, thank you.
Okay. Now let's do something more complicated. Okay, here we will go to the interpolation method. Let's again, we will maybe take the same example just to see that the same result can be just achieved by fitting, but not with the fitting, but just interpolation. Let's do it. Let's load our census, the same example with United States population. And we can again use, we already know how it looks, we don't need it, we just make just interpolation. How we can do interpolation with the same command fit in this way. We just make this argument and the function, and our method for interpolation, it's a linear interpolation. I believe we have no mistakes. And now we can plot it. Again, because this is fit, this is a structure, we should start from the structure. And again, we need the argument and the function. Let's see the result. Okay. It's something different. It's not what we get previously. You can see it. It's just piecewise polynomial computed curve. And it can allow us interpolation and get the point, the values inside our argument. And it's sometimes this interpolation, it's very important because it can allow us to smooth our observed data. It can fill the missing data. It also can make a prediction of the data. And it's very rich command for interpolation. And I hope we have time to do it today. Okay. For here, I believe there is no, I can show the, maybe let's see the structure of this structure and also the structure polynomial. Here you can see, here's F, it's our interpolant, it's our structure. Let me show it. Here it is. And this is its coefficient. We can order 2 and our coefficients also is here. Now let's go more interesting results of interpolation of 3D plot or 3D graph. Let's go, where is our example? We can just make it ourselves. Let's do it. Our first argument, or our first variable will be x. It will start from -3, and we will build it with the random addition. Random can be 6 multiplied by random, and the random will get 100, maybe it's better, 100 points, vector 1 column, and y will be, also can be -3 plus the same 6 multiply random, this the same hundreds, Now we will estimate the 3D function as a 3D function like sine of the first argument, and we will use power function in 4, and here we will multiply this result, by cosine function. Okay. Now let's try to see the results of this random data. We will use 3D plotting to show 3D plot, X, Y, V, and we will use circles with the color magenta, okay? Doesn't matter, but, and we will use gridding. I hope we have no mistake. No, we have using, okay, this is my fault. It should be dot here. Let's do it again. Okay. I will show the result. And we also can just play with this experimental, not experimental, this random points. You can see just a complicated surface that is difficult to interpolate, right? Do you agree? But we will try to do it. Oh, okay.
How does the random works in this Matlab code? Because your points are very similar to my points, and it makes me feel like it's not really random. You're writing random in this.
Have you multiplied by 6?
I did the same thing exactly like you, and it's very similar to you, which makes me feel like it's not really random. Like, what's the randomness coefficient? How can you tell it's really random? What's the Matlab is
okay
doing?
Our next example, if you have, now it's over 7 o'clock. Let me maybe finish this for random and not random. I have a next example how to distinguish between deterministic part in the function and the random part of the. We will use it autocorrelation function, but this is what the problem. I would like to tell some very important principle things of the data analysis, but we have no time for this. Let's. If you are interested, you will see it in my file that I will send, because I feel that we have no time for autocorrelation or cross correlation. Let's continue with this gridding. Now let's make interpolant. There is also quite complicated, but we will do it. We should this. This is also structure in Matlab, but it looks like this way. Scattered. Okay, it's now from the capitals interpolant. Matlab already helps me. Interpolant, and here we will use our two arguments and the function. Okay, we have our interpolant. Now we can make a mesh grid to plot the 3D plot. We will use mesh grid as xq, yq is equal to mesh grid. And we will start from -3, as we did with our random. We will take each 10 point and till the 3. Let's close this. Let's choose. We will do it with 3 different methods. Let me only check if we have no here mistakes. No, it's no mistakes. Now we will use 3 interpolation methods. The first one is equal. Here we will use also the structure because they have a different lengths of the names. This is why we can do it this way. We should double quotes use this. The first method is nearest. The second, also double quotes, please, linear. And the third will be natural. also in double quotes. Now, when we just plot all together. How we can do it? We can do it in a cycle. Let's do this, our cycle for I from 1 to 3, only three methods. Now, we will use our structure F with different method is equal to our character from our methods and I. Okay, now for each method we can make this interpolation. Our interpolation will look like this, and it's equal F our from X, Q, Y, Q, and it's enough, it's interpolation. Okay, and let's plot it. But first let's plot our original. We have already, let's take it from here. And plot ours. Ours, it's a mesh function or surf function. It's very, it could be or mesh or surf, and this should be X, Q, Y, Q, Y, Q1. Okay. Let me check. It looks like okay, but Matlab will. Let's here also. We before using, we need to keep the experimental. Hold on. Then ours. Then maybe title, maybe to understand the method. Title and method. Okay. What else? Legend we don't need. We need to plot each one with a different figure. And that's all. Okay. And we have, let's see if it works. We will clean everything and let's try. How strange it works. Okay. The first one, interpolation of our, do you remember our interpolation method? The first one, it was nearest. It's not the first. Where's our first? Here the first one. It's nearest method. The second one is linear. It's better, right? And the third one is natural. It's much better. Okay. I also can plot here the exact solution if we would like to have it. Let's do it, for example, next figure. And the exact was our function. We can just maybe estimate mesh as X, Q, Y, Q. And our sign, do you remember there is our sign? Here it is, our function that we were started. We will take it from here and we just put it here. And the only difference is the arguments. It's Q and YQ. That's all, and we can just see it. Let's start. Here, our analytic function. Also, we can see it in a large screen. And we can just play with it. It's our analytical function that we just interpolated with different three methods. Any questions, please?
How the natural interpolation works? How does it work?
How does it work? It just make, how, for example, we can make interpolation with the spline interpolation. How it works? It just minimize, it just nonlinear, also nonlinear optimization. It minimize the error between points of our real points. It just make a function between these 2 points, for example, as a spline, or maybe it can take 3 or 4 or 5 neighbors point. It make a function between this point, and it estimate the error between the interpolated analytical function and the experimental point, and try to minimize this error, least square method. And this is the result of the interpolation. Everything is based on nonlinear optimization.
Thank you.
You are welcome. Okay, I don't know. I think that I should continue, because in this case you will not get this smoothing. Okay, let's continue with the smoothing result, and we will maybe only talk about autocorrelation. Okay, again, Matlab can make smoothing. It's different thing. Fitting, interpolation, and smoothing, it's something different, but you can use any of them which is more convenient for your work. But smoothing, Matlab can do without any toolbox, because there is several functions inside. Let me show you. Let's build a new function. For example, xy is equal to from 0, from the increment 0 till 1. It's our argument. Oops, not here. And also we can make the anonymous function. Do you remember you already use it in May? It could be our x, and the function itself is just x dot, it's cube of the initial function, and that's all. Now we have here the argument and function. Let's calculate this, for example, where our results are x, y that we have, and our function. Okay, and let's add some noise, because it's very simple to do it without noise. Let's calculate the new bad results. Our bad results, it's our good results plus noise. Let's take some noise, multiply rand. Let's get here normal or size x. Oops. Okay, now we have bad results. Let's plot them together. We have
yi.
Sorry?
I think it should be yi.
Yi. Right. Thank you. Let's plot
xi.
This is the same size, it doesn't matter, but we can do it here also xy, but xy and us, right, you are right, because we have no x. Sorry, we have no x, it should be xy also, right, thank you. And plot, this is our argument, our function, and let's do it with the, for example, dot line, and now we will have the same argument and the same values, and bed, sorry, which here bed, and we will get it for with the x, for example. Let's see and grid. Let's see if it works. Okay, here our example. We have very, very noisy bad result of our estimation, and this is analytical, our analytical solution. Now let's try to smooth our bad results. For smoothing, we can use very simple Matlab moving average function. The name of the function is media filter 1. Let me show how it works. It could be Z, for example, as medfilt1. Our bed results with the noise. And here we can choose the size of the moving average. For example, 10 neighbors values in the function. Here we already median filter, medfilt1, medfilt1. Okay. Now let's plot the result. Let me take from here. I will take only maybe bed, or maybe both of them, and we can hold on and plot the third one. X, Y, and fit its result. But it should be Z, it's the result. And the color, maybe we should another color. What we have here, we have black, we'll have, let's take red. What we have here, you can see this is the result of med filter, just a median filter moving average filter. How it works, it takes each step, it takes 10, for example, in my example, 10 neighbors numbers, values, and just make from them average value. And this is our each first value. Then it goes for the next 10, and each time it estimates average and produce this.
Michael, you have a new message.
The result. Okay, now it's Matlab itself, but Toolbox, curve fitting Toolbox, it has a very power function, curved smoothing function application, curved CS apps. Let me show the example of this, of using of this function. We can again, maybe we should use the smooth first, because I promise. Okay, let's first do smoothing. The smooth also requires Matlab Toolbox, but it works very similar well. We can get bad examples from 10 enabled, and we can plot this as result. Here, let's take and now it should be Z1. Let's throw out everything and then try to plot smoothing. Okay, this is the smoothing result by using curve fitting Toolbox in Matlab. The command is smooth. And also we can use another very powerful fitting command, curve fit smoothing application, which looks like this. We can take the example, for example, let's produce our argument as a line space from 0 to 1, and the number of our numbers. Length x. And now we should choose the parameter of the smoothing in of this. Let's take, for example, smoothing parameter is equal to any number. And let's make the calculation. Our smoothing curve will looks like curve as applications. Our argument, our bit noisy results, our parameter, and this XX, our new argument. Let's see what we get. Plot the result. Maybe I will plot only the fitting result. It's XX and our result of our smoothing. We should choose color. Let's take green color. And let's do it with the gridding. Okay. This is, you can see that the result of fitting by using the curve fitting toolbox in Matlab, it's much better than median filter. And also I would like to show you, maybe we have time for 3D examples, okay? And autocorrelation and cross correlation I will send you separately before our third meeting. Okay, let's do it quickly. We have, for 3D, we need two variables argument. It should be, for example, we can make it as a structure, linspace from -2 and 3, and we will take 51 points. And also y should be a linspace, again from -3, okay, 61 points. It doesn't matter because it's y and x, they can be different size. Okay, now we can make the gridding. We can use, okay, x, y, y. By the way, we can use different functions for mesh. We can use mesh grid and we can use ND grid. Somebody knows the difference between N grid and mesh grid? Please tell, when I'm writing, please you can tell us the difference.
Maybe you can decide the size of the mesh grid. Right,
yeah. It seems that you always, you are right. Okay, it's 2. Mesh grid, it's just convenient only for 2 variables, just for plotting a 3D plot. But ND grid, it can be a number of meshing for many arguments. It could be 4, 5, 6 high size of the array or matrix. Right. Okay, now we have gridding, and let's use Matlab function peak. Maybe you already know what it peaks from what is in the original of the peaks. Why Matlab uses this peaks function? What is peaks function? What inside? What mathematical analytical meaning of the peaks? Somebody knows?
It finds the points of maximum value between 2 values.
No, not exactly. No, it's just example of 3D function, just part of the 3D Gauss distribution, nothing more. It's just example. And if we have time, we will understand why I choose it to show you. Okay, no, let's plot the noisy result the same. We will take our peaks and we will plus some random noise. Okay, random normal, it could be, and size our our y or x doesn't matter. No, y should be y. And let us just move it a little bit lower for the beauty. Okay, and now let's plot this surface. Again, x, y, and sorry, I forgot to calculate the smoothing. Okay, let's calculate the smoothing. No, we should do it after noisy result. The calculation looks like this. Smoothing calculation, let's this variable, this name is equal to C up, sorry, and we have x and noisy, and we should choose the value of the parameter. Let be 0. Close to the 1. Now we can plot it. We can plot it and should be our function. Okay, let me check if it works. No, it doesn't work. Why it doesn't work? Again, noisy, we have peaks and the grid. Let me check if y is the 3D function. Yeah, it's okay.
I think the inputs to the C subs is X and it should be Y.
Yeah, right. It's my fault, sorry. Right, now let's see. No, again, must be X must be a vector. No, it's, we have, no, X, we have, no, X maybe, X it's a vector, it's a X, X, Y, it's okay, Y it's okay, noisy, it should be Y, size random normal. Maybe I should use here, maybe first let's see if noisy, I can plot the initial function.
No, the variable y should be a matrix, right?
Yeah, should be a matrix, 3D, right?
You have a structure there.
Sorry. Yeah, but surface I can plot without structure. Surface. Let me check if I
mean SS val is structure.
X.
And I don't know if surf can take a structure.
But I'm sure that yes, it can. Let me check if I can plot before the initial value. Let us check if we can just make the initial one.
Just a second. So x and y are matrices, and when we call function peaks, the variable y is a vector. I see it's like 1200 by 1 vector, not a matrix.
Noisy. But peaks are okay. I check it. Noisy. What is noisy? It's just random size of the random. It's also should be okay. Noisy. It's okay. It should be. What they explain, X must be a vector. Line 58. But we have.
There's a null value inside of noisy, maybe. If you look at noisy.
You know what? Let me check. Maybe.
The X that you gave is not a vector, it's the matrix from the grid.
Right, but other way I cannot plot it without matrix. It's just, you see, it's a matrix.
No, the above line, the C steps.
Maybe here. No, it's C steps. No, I don't. What we can do, we can try maybe I have some examples. Let me check my examples. And let me replace this with mine, with the plotting. Let us check. First, let's clean here everything, and then let's try to play. Okay, now it works, but there is no difference as I see. Okay, there is noisy, our noisy function, peak function, Gauss distribution. Now we can make this estimation, this smoothing using the toolbox. Let's do it for function for C smoothing. And we will take this, we have now X as our argument, and should be noisy, our other function, and the parameters of estimation and X. I believe this way it should work. Let's check. Oh, no. Okay, now let's try to plot the surface. And our S valve, oh, not here. Okay, so without X's. Let's check. Oh, good. Now let me show just replacing the parameter of smoothing. We can make different results of smoothing. For example, the more this number is close to 1, that is the less smoothing. Let me show. If I take this number, it will be like the initial badly result. But if I take some small number, for example, this, okay, and now let me show why I put this example for you, because if you see this one, maybe somebody will recall this plot. Let's also plot with the color map. It was hot, if I'm not mistaken. No. Color, sorry, color map. And axis. Let us begin. Why my color doesn't work? Color map.
You wrote figure and then color map, but there is no plot.
Okay, right. Let's do it this way. Now, if somebody, do you remember this plot? Maybe somebody who is, how to say, a grown-up person. I like this plot because it was the first Matlab logo when Matlab started to be distributed among university, and this is what the first logo of Matlab. Somebody saw it in the past. Okay, maybe I'm too old.
Yes, in the square, the roundabout.
Right. It was an interesting plot. Matlab also choose his logo from the Gauss distribution. Okay, we should stop because we have already 2 hours. Let me ask you about questions. Do you have some questions?
Michal, what did you change now? Before it didn't work, and now it's working.
I don't know what I changed, but it was the same. But for me, I didn't find the error. But I I have this code that I check and I play with it before I plan and prepare this meeting, and I just copy from there and it works.
I think you added the X in the end of the C subs.
The end?
Yeah, the input for the CCAP steps was...
It is weird because it did.
Okay, if you know the error, it's good because I didn't find it, but now everything works. Sorry?
It still doesn't work for me.
Even
in the C subs function, is it supposed to be X in the beginning and X in the end, or also double X?
No, it could be double X here. You are speaking about this line. This line, you are speaking about this line?
The next line.
Here, I believe it should be X because we use we need the same argument to build this smoothing function. It doesn't work for it should be matrix. It should be two values matrix.
Maybe you can interpolate as well as smooth, so you can add the last input X can be a vector of more values. So you can interpolate as well as smooth.
Let's try. I'm not sure, but let's do it. If I took, for example, only one of them, let's see. No, it doesn't work. You see, it should be matrix. It couldn't be a vector. Do you agree? Our X is a matrix from the very beginning.
Okay, yes, I wasn't sure.
Okay, any more questions?
Michael, I understand you changed from 999 to 996, and this has made a difference for me.
No, it should. Let me show it. If I took, for example, 0.9, it should be also the pure. Let's do it. No, we have again some line. Again, it is. Sorry, I forgot the X. You see, if I took the smaller number of this smoothing, the better is the result. If I took a large number, for example, 4 nines, it should be just bad results of smoothing. Do you agree?
Yeah, I agree, but yes, now it worked for me as well. It's not changing, but I don't know. Before I did the change, and this is what happened, and instantly it worked. I don't know what the problem was.
Okay.
For me, the problem was the first x vector. When we put x instead of double x. If you put here again, like in ssval, in csaps, double x, then it will not work. That was our problem before, I think.
Maybe it was my fault. Maybe I put here double x. Yeah, it should be just matrix because double x, it's not a matrix. It's not a matrix.
Actually, I think double X is a matrix and X is a cell array because you have curly brackets.
Right. It's right. It's kind of structure, right?
So XX is in fact a matrix because you did ND grid with two
let's try
dimensions.
Let's try it twice. Let's try doing twice. Let's see if it works. No, it doesn't work. You see, we should just make the initial values.
Yes, so the input for CSAPs has to be a cell array maybe. But
yeah, okay, we should check it. Yeah, right. But now it works with these parameters.
Noisy is a matrix also.
X, yeah, X. We can see the size of X used here, for example. You see, it's just a structure. It's not just a matrix. It's an array.
What about noisy?
Sorry, what about
noisy?
Noisy. It's our initial plot here. This is our initial plot, noisy plot. It's also matrix, 3D matrix. It just
But how can it be matrix when y is a vector?
but surface can understand it. It can work without no problem.
Because it doesn't work with my.
No, but you should use the grading. You can see I use the grading to get the just matrix x and y. You see?
Right, and then you use peaks, and peaks a vector, right?
Peaks is just a function that can work with this x. Now, from this line, x and y, there are just matrix. You can see this is x, it's just matrix 51 by 61.
And y are matrix, but y itself, it uses peaks, so it should be a vector, right? No?
No, peaks. No, peaks also work with matrix. Peaks can be vector, can be matrix. Input for peaks. You can see it from the help. You can see it here. Peaks can work with vectors and with matrix also. Here it returns by matrix. It returns also the results. It also works with vectors, and also it works with the matrix. Do you agree?
Yes. Somehow,
okay.
I don't know. I have it like I wrote the exact same lines, but I get that y is a vector. I don't know why.
Can you use here the brackets, not bracket, not brackets, regular brackets, but these brackets that I use?
I use them.
Figure brackets, how to say in English?
Yes, I use them, but I don't know.
Okay, but now we finish with this example, but we have no time to speak about correlation and histogram and estimation and also many interesting subjects. But next time we will meet Monday evening, and I will send also files for this meeting. We will speak about analysis of vibration data. It will be interesting for me, for example, because many years I spent for analysis, and we will speak about windowing, filtering, spectrum analysis, and all these subjects connected to the vibration.
Fourier also?
Sorry?
Fourier?
Fourier, of course, because what is spectral? It's Fourier? Yeah, right.
Okay, and I will also, I think it can also be possible I will be happy to see more of the subjects on the course than, I mean, to use the time for the things you prepared.
But we have only 4 meetings. I try to do it, but you asked me to do it slowly, that you will just follow me. This is why even for today, we just made maybe less than a half a thing that should be described, speaking about data analysis and random analysis. We didn't speak about random at all. We didn't speak about auto-regression models. We didn't speak about histogram analysis.
Can you maybe send us the full code for what we should have done in this lesson, so we can do it by ourselves?
Right. Let's discuss this, settle this way. I will not send two files, R21 and R22. I will not send, because you should follow me. And 2 other that I prepared, I will send to you filled in with my code, with my examples, and you will learn yourself, okay?
Okay.